In this lesson, we will cover precision measuring instruments. Additional information on this topic can be found in the General Aviation Maintenance Technician's Handbook, pages 918 through 925 and 553 through 554, and in Advisory Circular 4313, Acceptable Methods, Techniques, and Practices of Aircraft Inspection and Repair, pages 76 through 77. There are occasions when you may have to add an extension to the drive end of a torque wrench. When an extension is added to the drive end, the actual torque will be greater than the indicated torque. To find the indicated torque that will give you the correct actual torque, use the formula given here. Here we can see where the values for A, L, T sub W, and T sub A in the formula on the previous slide come from. Here we can see an example of finding the indicated torque when the desired torque equals 150 inch-pounds, the length of the torque wrench equals 20 inches, and the length of the extension equals 5 inches. The torque value indicated on the wrench would be 120 inch-pounds if the desired torque was 150 inch-pounds and the extension and torque wrench were 5 inches and 20 inches respectively. Torque tables, such as the ones shown here, are used as a guide for tightening nuts and bolts when specific torque values are not called out in the maintenance manual. They are usually found in the manufacturer's service manuals. Here we can see the three scales on a vernier micrometer. Each numbered mark on the sleeve scale gives us the number of tenths of an inch, and each subdivision between them registers 25 1/100ths of an inch. The thimble scale measures in 1/1000ths of an inch, and the vernier scale measures in 1/10,000ths of an inch. The vernier scale measures in 10,000ths of an inch. To determine the correct reading on the vernier scale, you need to choose the line on the vernier scale that most closely aligns with a line on the thimble scale. This can be difficult and may require you to rotate the micrometer so that you are viewing each line in a flat plane and may require the aid of a magnifying glass. Here you can see that the line for 9/10,000ths aligns most closely with the line on the thimble scale. Let us determine what this micrometer is reading. First, there are two numbers showing on the barrel or sleeve scale, so we write down 2/10 or 0.2. After the number 2, we see 3 tick marks. Each is worth 25/1000ths of an inch, so we write down 0.075 or 75/1000ths of an inch. Next, we see that the line on the sleeve scale falls between the lines for 19 and 20 on the thimble scale. So we choose the lesser of these and write down 0.019 or 19/1000ths of an inch. And lastly, we see that the line for the number 3 on the vernier scale most closely aligns with a line on the thimble scale, so we write down 0.0003 or 3/10,000ths of an inch. Next, we sum all the numbers we wrote down to get a measurement of 0.2943 inches. In this example, we see the number 1 is the only number visible on the sleeve scale, so we write down 0.1 or 1/10 of an inch. Next, we notice that there are no tick marks visible after the number 1, so we can go on to the next step. The line on the sleeve scale falls between the 0 and the 1 on the thimble scale. The 0 is the lesser of these two numbers, so we can continue on to the last step. The line for the number 4 on the vernier scale most closely aligns with a line on the thimble scale, so we write down 0.0004, representing 4/10,000ths of an inch. After we sum these two values, we get a total measurement of 0.1004 inches.